Okay, this is the last lesson of chapter 2. Woohoo! We're looking at polynomial inequalities. So I put some steps at the beginning. It's totally up to you, but I do think that they help you formulate a process for how to solve these inequalities. So first of all, I would rewrite the inequality if necessary as a polynomial function on one side and the inequality of the inequality and then 0 on the other. So I do think that's important. Set the inequality equal to 0 in essence. Okay, then we're going to find the zeros and place them on the number line, right? And then we're going to choose real numbers to test between those zeros, right? And then we're going to kind of determine the signs and then choose the intervals that correspond to the correct sign. Before we actually do that, let's go ahead and just start. Let's just look at some graphs and make sure we understand what's going on with these. So, okay, we got two graphs. We're going to go ahead and start with this first one. We'll do it in blue. F of x equals 2x minus 1. So we're starting at a -1, and we're going up to over 1 each time, right? Okay. So we have a graph that looks like this. Okay. Then we're going to graph g of x, which is another way of saying y equals 5. So y equals 5 is a horizontal line. We've got this. Okay. So we've got our g of x, and we've got our f of x. So if I asked you when are they equal, right, they are only equal at one spot, right, the point where they intersect. So this would just be x equals 5. Okay. When we have f of x is less than g of x, we are saying when are the y values of f of x, right, so that blue line, less than the y values of g of x. So when is the blue line below the red line? As you look at that, that would happen everywhere over here on the left, right? So we usually write that as an interval, right? So we'd say, okay, when is that true for what x values? If it's the left side, the x values go to -infinity, and they stop at what x value? They stop at 3. I totally wrote the wrong x value on this up here. This should have been 3, not 5. I apologize for that. Okay. So now, as we go ahead and look at the next part, we're saying when is f of x, the y values of f of x, the blue line, bigger than or equal to the y values of g of x, that red line. So let's look at that interval. Okay, so it's starting at that x value of 3. And in this case, since it can be equal to, we will have the bracket, meaning we can include 3, but it'll go all the way to infinity. Okay. Next, let's look at the next one. So, by the way, we can solve this algebraically as well. That's what we're going to get to on the back side. Okay. Example 2, graph f of x equals x. So that's going to have a y-intercept of 0 and just have a positive slope of 1. So we've got something that looks like this. Okay, here's our f of x. Okay, our g of x then is x squared. So that starts at 0, 0 as well. It does go through 1, 1, 2, 4, right? Those are maybe just some points, 3, 9. Remember, you can always plug in points, but some of these graphs, they just expect you at this stage to be aware of and know. Okay, and this is our g of x. So here, we want to know when is x, so the blue line, greater than the red line, x squared. So in this case, it is on the interval, right? It's this portion of the graph right here. So that interval is what x values. It starts at 0 and it goes to 1. We do not have brackets, right, because it's not including those points. Analytically is a fancy way to say algebraically. So I'm going to have x is greater than x squared. We want to put 0 on one side, so I'm going to subtract the x. So we have 0 is less than x squared minus x. If you like having 0 on the right, you can totally rewrite this like so, but either way is perfectly fine. Okay. So we want to find the zeros over there on the left. So let's factor out an x. We'd have x minus 1 is less than 0. These two zeros then are x equals 0 and x equals 1. So we're now going to put those on a number line. We're going to have 0 and we're going to have 1. And those are our zeros. So we're now going to look at some test values. So we're saying, okay, like what if I plugged in -1? So let's plug in -1 into our equation. Let's plug it into like this part here. You could plug it in this step too, that's fine as well, but we just want to look at the sign. Is it negative or is it positive? So -1 squared is a +1 minus another -1, so it'd be 1 plus 1. That is going to be a positive number. Okay, choose something like a half. Got to choose something between 0 and 1. So I chose a half for 0.5. So 0.5 squared, that's 0.25 minus 0.5, that is a negative 0.25. The value, the actual number doesn't matter, but we want to know it's negative. Okay, so let's choose a number bigger than 1. I'm going to choose like 2. 2 squared is 4, minus 2 is still 2, so this is positive again. Which makes sense because when you have something like x squared minus x, right, that's just a quadratic, so it starts high, right, it went down, and it came back up. Okay, so in this case, we do want when it's less than, right, when it's less than 0. So do we want the negative or the positive part of the interval? In this case, we want the negative part of the interval. Since it is not equal to, we're not going to include the zeros. So as we look at it, we do get the interval from 0 to 1 with parentheses. Okay, let's go ahead and we're going to do some harder ones as far as our algebra goes. So these first ones I started off a little bit easier because I gave it to you in factored form, so the zeros are pretty nice and easy to tell, right? This one is x equals a -1, x equals a -10, and x equals a -2. So as you think about your number line, we're going to put those numbers on. We've got -10, -2, -1. Okay, we now got to decide some test values. So maybe I plug in a -11. A little trick here if you wanted, okay, actually I'm going to write it kind of down below. So if I have my factors are, 2 is not going to change anything, but I'm still going to write it. I've got x plus 1, x plus 10, and x plus 2. So when I have a -11, the 2 is always going to be positive no matter what part of the interval we're on. That doesn't change. But when I plug in a -11, this is negative, this is negative, and this is negative, right? -11 plus 1 is negative, -11 plus 10 is negative, and -11 plus 2 is negative. So then think about multiplying this. A positive times a negative is negative, times another negative is positive, times a negative is a negative. So this interval is negative. Choose a number between -10 and -2. So maybe I choose like -3. So the 2 is still positive. -3 plus 1 is negative. -3 plus 10 is positive. -3 plus 2 is negative. As we multiply a positive times a negative, we get a negative. Times a positive, still negative. Times another negative, we get a positive. So now we're between these two. So -1.5. I got a negative, I got a positive, and I got a positive. When I multiply that through, I get a negative. And as I look at this last one, we've got a positive. We got to choose something that's bigger than -1. I'm going to just choose 0. That's easy. So we get positive, positive, positive. As we multiply that, we get positive. Notice this makes sense because if you think about this graph, it's a third degree, right? Degree 3. It's positive, and everything's going to cross. So like, hey, if you think about it, it's going to start low. It's going to come up. It's going to go down. And it's going to come up again, right? That follows the pattern is another way to think about it. Okay, so now we want the part where it's greater than. So we want the positive parts of our interval. And in this case, we're not including those points, so they're going to be open circles. So now for our answer here, we would have -10 to -2 union -1 to infinity. Okay, let's look at the next one. So on this next one, let's look at our x values. X equals -12, x equals 2, x equals -8. Okay, -12, we've got a -8, and I got a +2. So I usually do write the factors here. The fact there's a negative out front doesn't matter. I'll put a -1 just so we don't get a little confused. So on every interval, we are going to have to multiply by another negative. we're going to have x plus 12 squared, x minus 2, and x plus 8. Notice this is squared, so like this whole thing is always positive. So really you just have the x minus 2 and the x plus 8 that's determining the sign. So if I plugged in like a negative 13, I would get a negative and a negative. So this interval, as I multiply a negative times a positive times a negative is negative. If I plug in like a negative 10, I do get a negative and a negative again. As I multiply through, I'm still negative down there. Okay? Between these two, maybe I plug in 0, so I get a negative and a positive. Last but not least, maybe I plug in 3, and I get a positive and a positive. So notice, as I multiply this, a negative times a positive times a negative times a positive is positive. And then a negative times all positives is a negative. Think about the graph. Degree 4, right? It's negative. It should go down on both sides. So it starts down. So if you wanted to think about the graph for a second, like, hey, it starts down. On 12, since it's squared, it bounces. Then it goes up through, and it comes back down. So notice, like, hey, the positive part's the one that's above, and then the negatives are the ones that are all below. So you could also totally think about the graph. That works as well. Okay, so let's go ahead and let's talk about the part that does work. So in this case, we do want the less than again. Oh, sorry, again, not again. We had greater than last time. So we're going to choose all the less than values. Notice we do not want it when it's equal to 0, though. So we still do need to skip over the zeros. So this interval is going to have 3 parts because we can't include that negative 12 since that is technically a 0. So we'd have the negative infinity to negative 12. We skip over it because it's not equal to negative 12 to negative 8. And then we skip to 2 to infinity. Okay, let's look at this next one. This next one, we do need to set it equal to 0. So let's move that 24 over to the other side. 9x squared minus 24x plus 16 is greater than or equal to 0. Something like that we want to factor. Unfortunately, there's not a GCF. But if I take 9 times 16, I get 144. On the bottom, I get a negative 24. This one actually does work out well. We get negative 12 and negative 12. So if I go through and rewrite the middle term as negative 12x minus 12x plus 16 is greater than or equal to 0, and I think about my grouping, I do get a GCF of 3x for the first one, right? And then I have 3x minus 4. For this next, I have a GCF of negative 4, 3x minus 4, greater than or equal to 0. So I do end up with 3x minus 4 times 3x minus 4, which another way to say is that 3x minus 4 squared. So here, we just get that x, if you think about 3x minus 4 equals 0, 3x equals 4, x equals 4/3. There's only one 0 this time, and that's just fine. Remember, it has multiplicity too. So you could plug in the numbers like we have been doing, right? Like, so I could plug in, let's say 0, and I plug in 2. If I plug in 0, I get 3 times 0 minus 4, so that's just negative 4 squared is 16, that's positive. If I plug in 2, I get 3 times 2 is 6, minus 4, that's 2, 2 squared is also positive. The other way to think about this is a parabola, it opens up, and this is multiplicity too, so hey, it just touches there, it's still positive. So in this case, since we do want greater than or equal to, we want this entire, and we can't include the 0 because it's equal to the entire number line. So this one did end up being all real numbers, or negative infinity to infinity. Okay, I've got to leave something for you to do on your own. So I'm going to leave this next one for you to do. I will say, hey, go about it and make sure you start by setting it equal to 0. So you are going to have to multiply this part out and move the 4 to the other side and then refactor it. If you have done it correctly, though, you should get an answer of negative 1, 3. So I'd recommend pausing the video, make sure you get that, and then let's look at E together. Okay. On E, we are going to go ahead, set it equal to 0, so we get x to the 6, x to the third minus 6 is greater than or equal to 0. You may look at this and be like, okay, that doesn't look hard, but the fact that it's the 6th power, not squared, it is a little difficult. So remember that little trick when we said let u equal x to the third? So then we just have u squared plus u minus 6 is greater than or equal to 0. That factor's super nice, right? U plus 3, u minus 2 greater than or equal to 0. So u equals negative 3, and u equals 2. So at this stage, just plug it in. X cubed equals negative 3, x cubed equals 2, which means x equals the cube root of negative 3, x equals the cube root of 2. Not necessarily the nicest of numbers, but hey, that's okay. Right? Like, so we may not be super familiar with what these values are. If it helps you, though, you could like do decimal approximation. So this is approximately negative 1.44. This is approximately 1.26. Or you could just say, hey, like, what does this graph look like, right? In general, it's going to follow, because it's even, right? It's a 6th degree. And it's positive, it's going to have both of the parts go up. So it's going to come up on both sides. So therefore, as we think about it, whether you think about the graph or you start plugging in some numbers, maybe you plug in like a negative 2, a 0, and a 2. And remember to then plug it into this part, like x to the 6th, right? We do get a positive, a negative, and a positive. In this case, since we do want the positive intervals, we're going to take the 2 outsides. Since it is equal to, we are going to have closed circles there. Okay, so this interval ends up being, hey, from negative infinity to the cube root of negative 3. We are including it, so bracket union the cube root of 2 to infinity. Okay, F, I think you're ready for as well. I think you can do F on your own. The one trick that I'll tell you here is that you can take out an x, and then you get a quadratic. So x equals 0 works. Okay, so then here, this one, if you do it correct, so just pause the video, try it on your own for a minute. Negative 5, 0, 11 to infinity should be your answer. And then let's look at this last one together. This last one says, okay, it's already set equal to 0. The problem is I can't factor that, right? X squared plus 1. So you may want to just think, well, how does, like, if I said just set this equal to 0, how would you naturally solve it? Well, maybe you'd subtract the 1 and take the square root, or maybe you do the quadratic formula, right? Technically here that we get plus or minus I. So we're getting imaginary solutions here. So maybe this is what I would say to myself, hey, is there ever an x value where this equation is true? So something that when you square x and you add 1, we're less than 0. Or you can even think about the graph, right? Like, hey, this is a parabola that shifted up 1 unit. Is there ever a part of that graph that is less than 0? And in this case, the answer is no, right? There's no part of this graph that's ever less than 0. So in this case, it's kind of a funky one, but there's actually no solution, right? Or sometimes what we put is DNE for does not exist, but not everything will work out for you, and that's okay. All right, I think you're ready to do the 2.6